Hello there, my name is Amal and 5 years ago I started my career in IT as a Scrum Master with no technical background. So I'm not a software engineer and I didn't learn how to code. And if you are working in IT and you don't have a technical background, I assume you've been through the same situation, like this. And if your team is asking you a question, your response will be like that. So, it was one of my objectives and the promises that I made to myself to learn and upgrade my skills and my knowledge to be able to understand the language that my team is speaking. Because for me back then, it seems like my team is speaking Chinese. I don't know any word of Chinese, so I didn't understand anything they were saying when it comes to technical concepts and so on. I know, as a non-technical person, you don't need to know how to code and you are not gonna code. But learning the basics of IT helped me gain more confidence, helped me contribute better to my team, communicate better with them, and also communicate better with the management about the progress of my projects. Since I went through that phase and that learning curve, I'm creating this series. It's called IT for the non-techie, where I'm gonna break down some of the IT concepts based on my experience and the things that I went through. And I hope it helps as many people as possible out there to gain the foundation knowledge and the basic knowledge to be able to understand what's going on around them. So if you are interested to learn more about the basics of IT, make sure to subscribe to this channel and like the video so I can feel motivated to create more videos. Also, don't hesitate to leave your comments about the video if there is anything I can improve. And if you have a specific concepts or specific things that you want me to explain and you want me to talk more about in details, just let me know. You can write a comment or you can contact me on my social media accounts in the description box. So, enough of the introduction. I will let you watch the first episode. It will be more theory and I will try to include more practical examples in the future. So I'll let you watch the episode.
When you think about the IT industry, your mind probably goes straight to coding, right? But here's the thing. IT isn't just about developers and engineers. There's a whole world of non-tech roles that are just as essential to making the magic happen. Let's explore some of these roles and see how they contribute to the success of IT projects. First, we have project managers, who are like the captains of the ship. They plan and oversee IT projects, ensuring everything stays on track, on time, and within budget. Without their organizational skills, things could easily spiral into chaos. Alongside them are business analysts, who act as translators between business goals and technical teams. They're the ones identifying what the business needs and finding solutions that work effectively. Then there are product managers, the visionaries who define the product strategy, set the roadmap, and ensure the final product delivers real value. They're the compass guiding the team toward creating something meaningful. Meanwhile, sales and account managers take the lead on the front line. They sell IT solutions, build client relationships, and ensure that customers remain satisfied with their services. On the support side, we have customer support teams. These unsung heroes troubleshoot issues, assist users, and provide invaluable feedback to the technical teams to improve products and services. And speaking of improving user experience, UX/UI designers focus on creating designs that are not only visually appealing, but also intuitive and functional. Their work ensures that users can navigate systems with ease. Before any IT product is launched, QA testers step in to save the day. They rigorously test every aspect of the product, finding bugs and recommending improvements to ensure everything works seamlessly. Alongside them are operations managers, who oversee infrastructure, vendor relationships, and service delivery. They're the ones making sure the technical systems support the overall business goals effectively. Finally, we have training specialists, who develop and deliver IT training programs. They empower teams and clients to understand and use IT tools efficiently, bridging the gap between technology and its users. As you can see, IT isn't just for techies. These non-tech roles are crucial to the success of the industry, offering opportunities for people who are skilled in leadership, problem-solving, creativity, or relationship management.
In
today's fast-paced IT world, non-tech professionals who understand IT basics have a distinct advantage. First and foremost, this knowledge enhances collaboration by bridging communication gaps with technical teams, making teamwork smoother and more effective. It also supports informed decision-making by enabling professionals to better understand system capabilities, risks, and opportunities. Understanding IT fundamentals enhances adaptability, making it easier to keep up with new tools and technologies. This adaptability strengthens problem-solving skills by enabling quicker diagnosis and resolution of technical issues. It also builds credibility in cross-sectional discussions, helping you gain respect and influence among colleagues and stakeholders. Pay basics also play a crucial role in supporting innovation. Non-tech professionals can spot opportunities, contribute fresh perspectives, and actively participate in growth initiatives. Moreover, understanding cybersecurity and compliance practices is essential for ensuring secure and compliant operations in any organization. Finally, IT literacy enhances customer focus by enabling clearer communication and better interactions with clients. It also helps align teams under a unified vision, ensuring cohesive project execution. In short, knowing the basics of IT isn't just helpful, it's a key to thriving in today's interconnected, tech-driven work environment. So, is acquiring technical knowledge difficult? Not at all. You don't need to dive deep into every technical detail. Instead, focus on gaining just enough knowledge to understand and effectively support your team. Think of it like learning key phrases in a new language. It's not about becoming fluent, but about communicating well enough to bridge the gap between business and technology. With a grasp of the basics, you'll be able to collaborate seamlessly with technical teams, make smarter decisions, and align technology with your role. Approaching this with curiosity and a growth mindset can make the process enjoyable. It's like solving puzzles or uncovering how things work. Plus, there's a real sense of accomplishment in seeing how this knowledge can empower your daily tasks and improve outcomes. And here's the best part. You don't need to know it all. A structured approach paired with hands-on experience makes learning manageable and even fun. So take it step by step and you'll be surprised at how easily you can learn. To truly understand IT fundamentals, it's essential to start with the building blocks that make technology work. At the heart of any IT system lies its hardware, the tangible, physical components that power and enable all digital processes. So what exactly is hardware? Hardware refers to the physical components of a computer system, things you can see and touch. This includes the CPU, central processing unit, for processing tasks, RAM, memory for temporary data storage, hard drives or SSDs for long-term storage, and input/output devices like keyboards, monitors, and printers. Networking gear like routers and switches also fall under this category. Think of hardware as the foundation, the machinery that makes everything run. While hardware serves as the physical foundation of a computer system, it's the software that brings it to life. If hardware is the body, software is the brain, providing the instructions and logic that make everything function seamlessly. So what exactly is software? Software consists of instructions, data, and programs that enable your hardware to perform specific tasks. Unlike hardware, software isn't something you can touch, it's intangible. Key traits of software include its ability to be updated, modified, and customized to meet various needs. From automating mundane tasks to powering apps and tools you use every day, software makes your tech work for you. Whether it's helping businesses operate smoothly or driving innovation in industries like healthcare and finance, software is the engine of modern technology. To fully understand how technology works seamlessly, it's important to recognize the role of a key component that connects hardware and software, middleware. This crucial layer ensures that all the different parts of a system communicate and function harmoniously. Middleware is like a translator or a middleman that helps different systems and software talk to each other. It sits between the hardware, operating systems, and applications, ensuring everything works together seamlessly. For example, a database management system, DBMS, is middleware that helps applications store and retrieve data efficiently. Similarly, API management tools allow apps to share information. Middleware simplifies development by providing pre-built functionalities like connectivity and data handling, so developers can focus on the bigger picture rather than reinventing the wheel. Hardware, software, and middleware may seem like separate pieces, but they work together to power the digital world. Hardware provides the structure, software brings it to life, and middleware ensures smooth communication. Together, they're the backbone of everything from your smartphone to large-scale enterprise systems. Let's explore the different types of software and how they contribute to the tech world around us. Breaking it down into categories can make it easier to understand their unique roles. The system software is the foundation of your computer. It works behind the scenes to manage your hardware and provide a platform for other software to function. Without it, your device wouldn't even boot up. For instance, operating systems like Windows, macOS, and Linux serve as the backbone of your computer, making it functional and user-friendly. Utilities such as disk cleanup programs or antivirus software help maintain and protect your system to keep everything running smoothly. Application software is what most of us interact with daily. It's designed to help you complete specific tasks or enjoy entertainment. Productivity tools like Microsoft Office and Google Docs support tasks like writing documents, creating spreadsheets, or designing presentations. On the other hand, entertainment apps like Netflix and Spotify bring movies, shows, and music directly to you, adding convenience and fun to your daily life. Programming software is the toolkit developers use to build the software we rely on. It plays a critical role in the creation of applications and systems. For example, code editors like Visual Studio Code and Sublime Text make writing and organizing code easier for developers. Compilers such as GCC or the Java compiler translate written code into a format that computers can understand, enabling developers to bring their ideas to life. Middleware works like a translator, helping different systems and applications talk to each other so everything runs smoothly. It's the behind-the-scenes connector that makes sure data and processes flow without a hitch. For example, database middleware links apps to databases, making sure data is shared accurately and efficiently. Embedded software is another essential type, though it's often invisible to the average user. It resides inside specialized hardware and enables these devices to perform specific tasks. Think of smart devices like thermostats or fitness trackers. They rely on embedded software to function. Similarly, your appliances such as washing machines and microwaves, and even vehicles use embedded software to power their advanced features. Together, these software categories form the backbone of modern technology. They work hand in hand to help us stay productive, entertained, and connected, while also powering the devices and systems we rely on every day. Behind every successful software product lies a well-defined process designed to meet user needs while maintaining high standards of quality and functionality. This structured approach is known as the software development lifecycle, a proven framework that transforms ideas into dependable working solutions. The software development lifecycle is a systematic, step-by-step process that guides teams through the creation of reliable and efficient software. It establishes a clear structure for key tasks, including planning, building, testing, deploying, and maintaining software. By following this framework, development teams can manage their work more effectively, align with business goals, and ensure that the software meets user expectations. SDLC is critical for keeping projects organized and on track. By breaking down complex workflows into manageable stages, it helps teams stay focused and ensures the final product is both functional and efficient. This structured approach not only enhances the development process, but also leads to software that delivers value and fulfills its intended purpose. Before diving into the technical aspects of software development, every successful project begins with a strong foundation. This foundation is established in the planning phase, the first and most crucial step of the software development lifecycle. During this phase, the project's scope, goals, and feasibility are defined, ensuring all stakeholders are aligned and setting the stage for a smooth and efficient development process. The primary objective of the planning phase is to evaluate the project's feasibility, identify potential risks, and determine the resources required to achieve business objectives effectively. By carefully assessing these factors, teams can create a clear roadmap that aligns with organizational goals and user needs, reducing uncertainties and setting realistic expectations. Key activities during the planning phase include defining the project's scope and goals, conducting feasibility studies, and gathering detailed requirements from stakeholders. This stage also involves identifying risks and developing mitigation strategies to address potential challenges. By thoroughly completing the planning phase, development teams establish a clear direction, minimize risks, and lay the groundwork for a successful project. This structured approach ensures the project progresses smoothly through the subsequent phases of the SDLC, paving the way for a reliable and effective software solution. Once the requirements are clearly defined, the next step in the software development lifecycle, SDLC, is the system design phase, where ideas and needs are translated into a comprehensive blueprint. This phase plays a critical role in defining how the software will be built, focusing on architecture, technical frameworks, and data flow to ensure seamless development. The system design phase begins by outlining the system architecture, which details the structure, components, and their interactions. This is followed by the creation of technical specifications that describe the functionality and purpose of each component. Another essential activity is designing data flows, which map how information will move through the system using tools like data flow diagrams, DFLEs. Additionally, teams select the most suitable platforms, frameworks, and technologies for development, ensuring that the chosen tools align with the project's requirements. The deliverables from this phase provide a solid foundation for the development team. The high-level design, HLD, offers an overview of the system architecture, including major components and their interactions. The low-level design, LLD, goes deeper, providing detailed specifications for individual modules and their functionalities. UML diagrams further enhance clarity by visually representing the system's structure and behavior, making it easier to understand and implement. By the end of the system design phase, the team has a clear and structured plan to guide the development process. This ensures that coding is both efficient and accurate, minimizing misunderstandings and setting the stage for a successful software build. The implementation phase marks the moment when the software begins to take shape. This phase is all about turning the detailed design from the previous stage into a working application. Developers translate the design documents into actual code, adhering to established standards and best practices to ensure the software is high quality, maintainable, and aligns with the project's objectives. During implementation, the primary focus is on code development, where developers write the code for each module as specified in the design documents. Following coding standards and industry best practices ensures consistency, readability, and long-term maintainability of the software. Another critical activity in this phase is unit testing, where individual components are tested to confirm they function correctly and meet the outlined requirements. The outcome of the implementation phase is a functional software application, a tangible working product that aligns with the specifications defined during the requirements and design phases. This working product forms the foundation for subsequent testing and deployment stages. The implementation phase is a pivotal step in the software development lifecycle. It transforms plans and designs into a real operational application, setting the stage for thorough testing and eventual deployment to end users. The testing phase is a crucial step in the software development lifecycle, SDLC, dedicated to ensuring the software functions as intended and meets all specified requirements. This phase focuses on identifying and resolving defects or issues, guaranteeing the product's quality and reliability before it reaches end users. During testing, various types of testing are performed to validate the software. Functional testing checks each feature against the defined requirements, ensuring everything works as expected. Integration testing evaluates how different modules interact, confirming they work together seamlessly. System testing assesses the software as a whole within a complete environment, ensuring it operates as intended under realistic conditions. Finally, user acceptance testing, UAT, involves end users validating that the software meets their needs and is ready for deployment. Another key activity in this phase is bug identification and resolution, where testers log defects and collaborate with developers to address issues promptly. This iterative process helps refine the software, ensuring all problems are resolved before the next phase. The outcome of the testing phase is validated software, a reliable, high-quality product that aligns with user expectations and performs as intended. By thoroughly completing the testing phase, teams can confidently deliver a defect-free application that meets both business objectives and user satisfaction, paving the way for successful deployment. The deployment phase is the combination of the software development lifecycle, SDLC, where the software transitions from development to its operational environment. This phase ensures the software is fully functional and ready for use by end users, marking a significant milestone in the project. Deployment begins with the release to production, where the software is deployed to the live environment. This process is often conducted in phases such as a pilot release to minimize risks and address any last-minute issues. Alongside deployment, user training is conducted to equip end users with the knowledge and skills to operate the software effectively. Additionally, comprehensive user manuals are created to serve as a guide, helping users navigate and utilize the software with ease. The outcome of this phase is live software, a fully deployed product available to end users, ready to deliver value and fulfill its intended business goals. This transition signifies the software's readiness for real-world application and marks the beginning of its operational life. The maintenance phase is a vital part of the software development life cycle, SDLC, that begins once the software is deployed and in use. This phase ensures the software remains functional, reliable, and aligned with evolving user needs and organizational goals. It focuses on sustaining performance and adapting to changes over time. A key activity during maintenance is monitoring performance, where teams continuously track the software's behavior to detect and address potential issues early. Bug fixes and issue resolution are also integral, ensuring that any defects or errors reported by users or identified through monitoring are promptly resolved. Another critical focus is on regular updates and enhancements. This involves implementing updates to improve functionality, security, and performance, while adding new features in response to user feedback and changing requirements. The outcome of this phase is reliable software, a system that continues to perform efficiently and adapt to new demands. This ongoing effort ensures long-term user satisfaction and helps the software maintain its value over time. Thank you for joining this session on IT for non-tech professionals. We've covered some essential topics to help you feel more comfortable navigating the tech world. This is just the beginning of your journey. We'll be sharing more content soon, diving deeper into practical tips and insights to help you grow even further. So stay tuned. If you enjoyed this video, please subscribe to the channel and share it with others who might benefit from it. Your support helps us bring you more useful content. Thanks for watching, and we'll see you in the next video.